Hi dear students, welcome you all to the next set of the video from NCERT based physics electrostatics question discussions. We already discussed two video from electrostatics. Question number 1 to 10 is in one video. Question number 11 to 20 is in the second part of the video. Now this is a third video, question number 21 to question number 30. As like you know, in the first two part of the video, we have followed a certain method, a certain approach. The same method we are following in this video also. We are reading the questions, we are understanding the question, and we are learning the theory behind the problem. Then we are going to the problem solution for the detailed solution of the problem. This is a method in which we are following. The same strategy we are doing it here also. Now, for a reminder for you, if you have not watched the first 20 questions, split it as a two video. For you, I have placed it in the video description or in the comment section, the link of the particular video. And those who are new to this channel, if you would like to see our NEET based lecture series, which means electrostatics complete theory lessons are open in our YouTube channel. It's completely free of cost. You can go and see those videos also. I'll pin that link in the group description or in the comment description also, so you can go and watch it there if you would like to learn this chapter in a very deep way. So we are moving to the question number 21, that is the third part of the video. First question: an uncharged sphere of metal is placed between two charged plates as shown in the figure. Lines of force appear as. What is called lines of force? Lines of force is nothing but electric field line. So question is given, we have two plates. One is the positive plates and another one is the negative plates. And we have a ball, a sphere is placed in between the plates. Question is asking which of the following option is matching the right electrical lines of forces. You can see electric lines of forces in all the four diagram, but with different shapes. Which one is matches with this one? This question is taken, or the question is based on NCERT section number 1.8 electric field lines. We learned some theory behind this problem, then we'll come to the detailed solution of this one. So the theory behind this problem, that is called the key point, is that properties of electric field lines. Field lines will never intersect each other. I already told this properties in the second part of the video also, but once again we will recollect it for our better understanding. So field lines are never cross each other, because which means if you have one field line like this one, then you should not have a field line like this, because here there is a cross. This is not allowed. Point number 2, they are perpendicular to the surface. So if you have a surface like this one, whatever the surface, electric field lines either coming or leaving the surfaces, but which makes how much angle? 90 degree to the surface, perpendicular to the surface. Third point, electric field lines, the field is strong when the lines are close together, and it's weak when the field lines are moved apart from each other. What is the meaning of this one? So field lines are strong when the lines are close together, which means if I have a electric field lines which are coming very closer each other, then I will say here electric field is a large value comparable to the second diagram. So here electric field will be less. So more number of electric field lines means more stronger the field. First one is more number of electric field, more stronger. Second diagram, less number of electric field, less stronger the electric field. Point number 4, number of field lines directly proportional to the magnitude of the charge, which means, say for example, I have 6 coulomb charge, I have 2 coulomb charge. So 6 coulomb charge will have large number of electric field lines comparable to 2 coulomb charge. So for example, 2 coulomb charge will have here 3 lines, but 6 coulomb charge will have here 5 lines, which means simply number of lines are more for more value of charges. Fifth point, electric field lines starts from positive and ends at negative. You have a positive charge here, you have a negative charge here. Electric field lines starts from positive and ends at negative. Sixth point, if the charge is single, then they starts or end at infinity. Say for example, if you have positive charge, they starts from here and go into infinity. Other way, if you have a negative charge, they are starting from infinity and they are ending at negative charge for one charge case. Seventh point, the lines curves are continuous in charge free region. Lines are continuous. Continuous means like this. It should not break. The field lines, if you have positive charge here, if you have a negative charge here, it should be like this, but it should not break like this. It should be continuous lines. Okay, so these are the 7 properties of electric field line. You don't want to by heart the electric field lines as like your board examination, but at the same time you should understand, okay, this is how it's look like. Now we will apply one of this rule into this diagram. Here field lines never cross each other. So in any one of the diagram, field lines are not crossing each other. They are perpendicular to the surface. Second point, they are perpendicular to the surface. If you look, will be here for the first diagram. Here it makes 90 degree, but here it's not making 90 degree. Here it's not 90. So this diagram is false. And for a metal sphere, very important, for a metal sphere, electric field lines never passing through the sphere. What is the reason for this one? Suppose if you have a metal sphere of positive charge, say this is a positive sphere. So electric field lines are going out here, going out here. So these two field lines are opposite to each other and they cancel electric field at the center equal to 0 for a sphere. Say for example, the other two side charges, electric field lines come like this, electric field here, electric field here, electric field here. So all the electric field lines are traveling in opposite direction and they cancel each other. So electric field inside the sphere equal to 0. Okay, uncharged metal, a sphere of metal is placed between the two plates. So electric field lines inside the sphere equal to 0. Here you can see in the second diagram, electric field lines are passing through the sphere here. This is the problem here. This makes this option is an incorrect option. Look into the third diagram. Electric field lines are continuous. Electric field lines are perpendicular to the surface. So here is a surface. It's 90 degree, 90 degree, 90 degree. Everywhere it is 90 degree, correct? And it is not passing through inside the sphere. Inside the sphere, there is no electric field lines are there. So this is a correct option for this question. If you look into the fourth option, this is not 90. This is not 90. This is not 90. So majorly here option is, here the option 3 comes because electric field lines inside the sphere equal to 0. And one another point, the electric field line should be perpendicular to each other. So we will add one more additional point here, which means what is the point? Electric field inside the sphere, inside the sphere equal to 0. Let's have a small diagram also to understand the background. Say for example, all these are positive charges each other. Then what will happen? The electric field lines are traveling opposite. All are cancel each other and the net electric field equal to 0 inside the surface. So this is the two key point in the question. This is already given in the NCERT textbook, but we have marked or we have added this point here to solve the problem. So this is a theory based on the theory according to property number 2. What is the property number 2? The field lines are perpendicular to each other, like perpendicular to the surface. So according to the option number 2, property number 2, option number 3 is the correct answer. Once again, I'm repeating, this is the correct option because of 90 degree and electric field lines are not passing through the sphere. Okay, I hope you understood. Let's move to the next question, question number 22. A thin glass rod is bent into a semicircle of radius r. a charge q is uniformly distributed along the upper edge, and charge minus q is uniformly distributed along the lower half as shown in the figure. The magnitude and the direction of the electric field produced at the point P, center of the circle will be. So we have a semicircle will be here, and the upper half of the semicircle is covered with the positive charge. Lower circle is covered with the negative charge. And we are asked us to find out what is the electric field at the point P. So this question is taken from NCERT section 1.41, field due to infinitely long charged conducting wire. That is actually the topic. So this question is a derived question from the particular topic or a particular area. Okay, which means simply section number 1.41, it's a charge, the continuous distribution of the charge, that is a section number. So 141.1 is the subheading under 141 section, field due to long straight uniformly charged wire. This is actually a charged wire only, but not infinite length, but it's a finite length. So infinite length is a heading. Under this one, various categories are covered in NCERT textbook. So this is a finite wire, but it is bent in the form of a half circle. And first quarter circle here, this quarter circle, what is the angle of quarter circle? 90 degree. So this quarter circle will have an angle of 90 degree is positive sign, and the lower quarter circle here, so this also have 90 degree, the lower quarter circle have minus q charges. So question is asking what is the electric field at the point P. Okay, we learned little bit of theory, then we'll come to the problem, so that in entrance examination you able to answer all such model of problems. So we will learn the key concept behind this problem. What's the theory talking about? Let's say if you have a arc, a wire like this, wire in this bend in the form of an arc, and the arc will have an angle of phi, arc will have a radius of r. So electric field is going along the direction and passing through the center. So that is marking the direction of electric field. So electric field in a value 2k lambda divided by r into sine phi by 2. The same problem, not the same problem, same concept, or based on the same equation, we have discussed another problem in the part 2 video also. So this is another flavor of that particular formula. What is called lambda? Lambda is called linear charge density. I will write it here. This is called linear charge density. Linear charge density. Lambda equal to charge divided by length. So charge means charge of this arc divided by and length. Okay, so if you take a negative sphere, a negative arc like this one, so what is the formula? Same formula is applicable here, but the only thing is that the direction of electric field is varying. For a positive charged particle, direction of electric field is going away. For a negative particle, its direction of electric field is coming towards the metal strip. But formula will be the same. Only direction of E will be various. So you must remember, or you must note down this formula. This is the key point will be here. Key point, this formula. 2k lambda divided by r into sine phi by 2. Now we will analyze the problem, what it is given. So I just copied the diagram which we have given in the problem. So we have a positive sphere here, it's given. This is a positive part. So which given an electric field in this direction. So electric field is marked here. And this is a negative part. So from this point, these electric fields are coming like this. I extended to this direction. Now the angle between them is 90 degree. Exactly at the middle, it is 45 degree and 45 degree. Exactly. So now the E is split as two component, E sine 45 and E cos 45, because electric field is a vector quantity. Second one, here also we have another E because of for the negative charges, which is split as E cos 45, E sine 45. You can see that electric field is a vector quantity, and the electric field E sine 45 and E sine 45 are moving in opposite direction. So what happened? They are equal in magnitude and they cancel each other. So what is the total electric field? We have E cos 45 and we have E cos 45 in the downward direction, in the downward, this direction. This is a direction. This making 90 degree with the OP, 90 degree with the OP. It is moving in the negative y direction. So total electric field is 2E cos 45. Total electric field is 2E cos 45. This is actually we need to find out. So now we know the formula 2k lambda divided by r into sine 5 by 2. So first we will take one half, then we'll take the next half. Okay, for a half circle, the angle equal to 180 degree. But we have two quarter circles here, first half here, second half here. So for each half it is 90 degree. That's what we are taking. E is either due to electric field due to plus Q or due to minus Q. So it is 90 degree, first half or second half, same magnitude on. So 2k lambda by r into sine 90 by 2 for each quarter of the circle. So what is electric field? 2k lambda by r sine 45. Sine 45 is 1 by root 2. So this 2 can be written as root 2 into root 2. So 1 root 2 got cancel each other. So you have root 2 k lambda by r. This is the electric field. Now what is the total electric field? I already told, E cos 45 plus E cos 45. That is nothing but equal to E net electric field 2E cos 45. What is E? Root 2 k lambda by r. Substitute. We already calculated the value here. So this value actually coming to here. 2 root 2 k lambda by r into cos 45 is 1 by root 2. Again this root 2 get cancelled. You will get 2k lambda by r. But this option is not given like 2k lambda by r. Option is given in terms of epsilon 0. So we are changing the k. K means 1 by 4 pi epsilon 0. Already you know. And capital R. R is the radius. Question is given capital R. The radius are small r. So capital R equal to small r. What is lambda? Lambda equal to charge by length. Lambda equal to charge Q length. ഒരു full circle length means 2 pi r ആണ്. ഒരു half circle length 2 pi. ഒരു half circle, full circle length equal to 2 pi r. ഒരു half circle length means 2 pi r divided by 2. Here we have lambda is actually we have positive charge, we have negative charge. So all together we have a half circle. So half circle length is pi r. This pi r come actually 2 pi r divided by 2 cancel pi r. So q by pi r. So k equal to 1 by 4 pi epsilon 0, r equal to lambda equal to q by pi r. We are substituting this value to E net. So E net equal to 2 into k value 1 by 4 pi epsilon 0, lambda value q by pi r into 1 by r. 1 by r. So we have this r, small r, capital R will be here. That is actually come here as 1 by r here. So what happened? This 4 and 2 got cancels and we got 1 divided by 2 pi square epsilon 0 pi r square. Okay, here I have written an extra pi. So this actually, so this pi into pi is actually we have only 1 pi, right? So we have totally epsilon 0, we have r square. So 2 pi square epsilon 0 r square. If 4 2 cancel, so balance is 2 pi into pi square epsilon 0 r into r square. So 1 by 2 pi square epsilon 0 r square. That is the correct. That is matches with option number 2, I guess. Let me see. Option number 2. Yes, it is q by 2 epsilon 0 pi square r square perpendicular to the line OP, perpendicular line OP and directed towards downward. This is actually our 2e cos 45. Yes, this is the correct answer. So option number 2 is the correct answer for this problem. Okay, it is perpendicular to the line OP and directed towards downward, that's the thing. So option number 2 is the correct answer for question number 22. Once again reminding you, this question is from 141 section of NCERT. NCERT section like continuous charge distribution. It's one of the highly important topic. Normally I have seen both for IIT JE examination and as well as for medical entrance NEET examination also, one question is always coming from that area. So please don't skip the area, please study very seriously. Okay, let's move to question number 23. What is question number 23? A circular wire loop of radius r carries a total charge q distributed uniformly over its length. A small length dl of the wire is cut off. Then electric field at the center due to the remaining wire. I already told you, for a circular wire loop of radius r, what is the total electric field will be here is 0. In question number 21 we are told it is 0. So electric field at the center equal to 0. So all electric field lines are opposite to each other, but total electric field will be equal to 0. Now let's say one example. So if you have a charge sphere like this one, and if you cut this portion, this will give a 10 Newton per Coulomb electric field. Then the remaining portions will also give how much? 10 Newton per Coulomb electric field. So these small portion will definitely needs to cancel with the bigger portion, because for a circular wire loop, electric field at the center equal to 0. So electric field, this value, this small piece in electric field value is equal to the higher piece in electric field value. And it is equal, but it is opposite direction. Because for a full circle, electric field at the center equal to 0. So if you have a small portion and if you have a bigger portion, both giving a same electric field, but they are acting in opposite direction. That is the importance here. So question is asking, what is the electric field due to the remaining wire? Instead of finding the remaining wire, you can find electric field due to the small wire, because both are magnitude wise equal, direction wise opposite. Okay, so again this question is taking from section 1.1 to continuous charge distribution. Important on NCERT sections, frequently questions are coming from this area. Now let's learn some theory behind this one. Electric field at the center of a circular wire equal to 0. We already told these things many times. So here we have to conclude that electric field due to dl, small length of the wire, and electric field due to the rest of the wires are equal and opposite direction. So electric field due to the wire of length dl is given by electric field equal to 1 by 4 pi epsilon 0 lambda dl by r square. What is lambda dl? You know, normally we have written electric field formula 1 by 4 pi epsilon 0 q by r square. We know lambda equal to charge per small length dl, big length L. So q equal to, so once again I'm writing 1 by 4 pi epsilon 0, we have q by r square. So we know lambda equal to q by dl for a small length. So q equal to lambda into dl. So this is actually coming here. So q is replaced by, here the q is, this is actually equal to q. So we have a small piece of wire whose length is dl, and at a r meter away electric field is E. We are calculating the value of the electric field for a small piece of the wire. So what will be the electric field for a bigger piece of the wire? That is equal to small piece of the wire, but they are acting in what direction? Opposite direction. Okay, they're acting in opposite direction. So now based on this one, we are going to find out electric field due to a small piece of the wire, that is K lambda dl divided by r square. What is lambda? We have a full sphere. So I told charge divided by its length. For a full sphere, full sphere, the full circular length equal to 2 pi r. This is in mathematics is called perimeter. Important on it. If you don't know, you should learn now. Q by 2 pi r, dl divided by r square. That's it. The answer is over. So Q dl in the numerator, denominator 8 pi square epsilon 0 r cube will come. That is matches with option number 1. So option number 1, Q dl 8 pi square epsilon 0 r cube. Option number, okay, option number 1 is the right answer for this question. Q dl 8 pi square epsilon 0 r cube. Important on continuous charge distribution. I have an humble request for you. If you are preparing for NEET or JEE entrance examination, please do not skip the particular area, because it's very important. I have frequently seen question from this particular area. So let's move to question number 24. Question number 24, here it is. 2 point-like charges A and B, point-like charges A and B, whose magnitudes are same. Like means here magnitudes are same, are positioned at a certain distance from each other. A is the origin. Graph is drawn between electric field E and distance x from A. Electric field is taken positive if it is along the line joining from A to B. Question is asking and graph is given to you. You don't want to draw a graph. So this is an electric field versus X graph. So question is giving a major hint. The electric field E at a distance x from A, E is taken as positive along the line joining from A to B. A to B means positive x direction. Positive x direction to positive E. You have to consider like this. This is what they have given in the question. So of course in minus x direction, what will be the electric field? It should minus E. Okay, now this question is again comes from the section of 1.8 electric field lines. We want to know the field lines. So to know the field lines, there are 4 options are he will be here. A the charge positive or negative, B the charge positive or negative. What is the answer? Both are positive, both are negative, one is positive, one is negative. We don't know, we have to calculate this one. That is the aim of the question. Definitely we should learn a lot of theory will be here. Let's move to one by one. Okay, now we know electric field lines for a positive charges, field lines are always going out. For negative field lines are coming into the charge. And both cases, electric field lines, when the distance increases, electric field reduces because distance is in denominator. Positive x direction, we have positive electric field. Negative x direction, we have negative electric field. These are the standard conventions, and this is also given in the question. Next, let's take some examples here. So we are interested about what is happening in between the charges. We are not interested what is happening outside the charges. See here, due to positive charges, electric field lines are going like this, and this is the electric field, then that is positive. Why? Because electric field along the direction of from where to where we are moving from A to B. From A to B, electric field lines is positive. Other side, I am assuming in B also we have a positive charge. So electric field lines are going away from positive charge left kum right lotum. But left case for us it's important. In between the charges, what is happening? Because the graph is asking what is happening in between A and B. Not left of A, not right of B. This is not interested in the question. So that's what we are also interested in between this one. So now the electric field lines are coming left to right, and right to left from right side. So definitely exactly at the middle, these two feed lines are equal and they cancel each other and then become electric field equal to 0. This is what I have written here, electric field equal to 0. We are moving from left to right for the first two charges. Here we have an electric field in a formula kq by r square. So x is the distance, x is nothing but r, the distance. When x equal to 0, so x equal to 0 means electric field is how much value? Infinity, very high. Electric field is very high. Here distance is less. Once you are moving towards right side like this one, what happened? X increases. When x increases, what is happened to the electric field? Reduces. That's why the graph is coming downward like this. Any other side load will go. We'll go to the B side. B side we are starting from here. For left side is starting from A, left side is starting point is B. So B we are moving left side. Left side of form electric field is negative. That's what this is plus E graph and this is minus E graph. Let's mark it as this is minus E and this is plus E graph. So graph definitely falls in the negative part, bottom part graph falling. So if you are moving left side, what will happen? Here you are here and here x equal to 0 I have to consider, and here if you are moving left side, distance increases. When distance increases, x increases, what will happen to electric field? Electric field reduces. That's what at the point here electric fields are coming down like this. So exactly at the point B we have more electric field and the electric fields are reducing when we are going away from B, and exactly at the center these field lines are opposite and they cancel each other at the center, electric field equal to 0. Important on same story or the same stuff I have taken a very detailedly in the theory video. As I told, the theory video, electrostatics theory video is available in the group link description also. Please watch those theory video after the problem discussion also, so that you will understand what are the area you have to concentrate. Not go and watch now. First you listen here, then after this one you can go and watch it. Next, let's take at the second cases. Second cases A is positive and B is negative. Now if you see, in between the charges we are interested, electric field lines are going away from positive charge. So here electric field is positive because in the positive x direction. For negative charges, electric field lines are coming inside. I have marked here yellow lines. Yellow lines means in between the charges I am interested. Outside I am not interested. So here electric field is positive because electric field lines are moving in the direction for negative charges, like towards the charges. So positive x direction, positive. Electric field lines are going away, positive x direction, electric field is positive. Like this is nothing but plus x direction. This is nothing but plus x direction. If it is plus x direction, but in the previous diagram, this is also in the plus x direction, but this is in the minus x direction. So here we have both are in the positive x direction. Left to right lot on arrow mark. So രണ്ട് സൈഡിലും positive ആണ്. So you have positive part here, you have a positive part here, no doubt. So when distance increases, again distance increases, what will happen? Electric field reduces. Electric field reduces. Here also electric field reduces. Both side. Okay. So this is actually our question. And question option number 1 is the correct answer. Option number 1 means A is positive and B is negative. But we will learn more theory here also. What happens if both are negative? Let's see. Now you can draw the diagram yourself. Now we have a 2 points will be here. This is a point A and this is a point B. So we have 2 points will be here. So at this point, you can take it as a origin also. For better clarity, I just moved a little towards right side and B I keep it there. So in between the charges, negative charge, electric field lines are moving towards the charges. So this is in what direction? This is in minus x direction. And the right side, here B side, electric field lines are towards the charges. So this is what direction of this electric field? This direction is in the positive x direction. So positive x direction, you have positive electric field and here also you have negative electric field. So negative means first part is negative, this graph, and another part is positive. Okay, now you can see here electric field lines are moving like this. Here electric field lines are going like this one. So what happened? Electric field lines are equal magnitude moving in opposite direction. Exactly at the center, electric field value equal to 0 will come. So positive part of the graph, negative part of the graph. So E negative means definitely negative part. E positive means E positive. If it is in opposite direction, definitely you have a point where E equal to 0. Definitely you have a point E equal to 0 if it is in opposite. Other, if it is coming from left to right like this or moving in opposite direction also, you have a middle point where electric field equal to 0. Next one, what happens if negative and positive comes? So negative and positive come means we have 2 points. One is our A and another one is our B, and we have an electric field due to the negative charges towards the charges. So E is negative because we are moving in minus x direction, and because of the right side positive charges also, electric fields are going away from, not towards the charges. No, it's negative. So electric field lines are going away. So electric field is negative because it is moving in left direction. So it is moving in minus x direction. So both are, one is moving left side, another is moving left side. So same direction. So electric field will never equal to 0. Electric field will be equal to 0 when both are opposite direction. Here not opposite direction, same direction. So electric field is negative. You have this left part of the graph here. Electric field negative, you have the left part of the graph. Here distance equal to almost equal to 0. So x is almost equal to 0. Electric field is very high. When x increases, electric field reduces like this. This is what happens. So minimum electric field. Here also, here from the point B is starting. From the point B, you can take x is equal to 0. So if you go here, x increases. If you go here also, x increases. When x increases, electric field reduces. So that's what the graph is moving like this. Okay. So all the possibility we have covered here, negative and positive, negative and negative, positive and negative, positive and positive. All the 4 cases are covered. So any one question you can expect that answer. But for us, this is actually the question given for us, that is option number 1 is the right answer. What is option number 1? A is positive, B is negative. Never by heart the problem, understand and then do it. Then it will be easy. Okay. So let's move to question number 25. Electrical potential at a point in free space due to charge Q coulomb is Q into 10 raised to 11 volt. Electric field at that point will be what? Electrical potential at a point in free space. Electrical potential is given. Electric field we need to calculate. This question is taken from NCERT section 2.3, potential due to a point charges. Potential section. We'll learn some theory. What is electric field? Electric field equal to KQ divided by R square. Equation number 1 quoted here. Potential equal to KQ by R. R equal to KQ by V. This just rearrange the equation. So R is taken here and V is taken back here. So R equal to KQ by V. We have equation number 1. We have equation number 2. Equation number 2 substituted in equation number 1. So electric field in the R ഇവിടെ substituted. So what will get? KQ divided by KQ by whole square. So V square will go to numerator. So it become V square divided by KQ. Only this formula we are using it here. So electric field potential value, V in the value, it's given in the question, Q into 10 raised to 11 and the square divided by denominator KQ, capital Q on, so KQ. We are solving. So it become Q square 10 raised to 22. K in the value means 1 divided by 4 pi epsilon 0. So this will go to numerator. So 4 pi epsilon 0. So Q square Q cancel. 4 pi epsilon 0 q into 10 raised to 22 electric field in the value unit volt per meter. Electric field in a formula and force by charge, so its unit become Newton per coulomb, or is equal to voltage by distance, volt per meter. So it has a 2 units and basically 2 fundamental formula. So either Newton per coulomb will come or volt per meter will come. Here volt per meter, 4 pi epsilon 0 q into 10 raised to 22 volt per meter. This is option number 3 ആണ്. 4 pi epsilon 0 q into 10 raised to 22. You see volt per meter. Option number 3 is the correct answer for this question. Okay. Now we are moving to question number 26. Electrical potential at a point x, y, z is given by V equal to minus x square y plus 4z. Potential is given to you here. Question is asking what is the electric field at the point. This is a very common question. So section 261, relation between electric field and the potential. So this question is taken from the sections relation between electric field and potential. Straight away question. You have to learn only one formula. What is that formula? Let's learn some theory. That's it. Relation between electric field and potential. Electric field equal to differentiation of potential dV by dx I cap minus dV by dy into j cap minus dV by dz into k cap. If you learn this formula, that's it. So electric field equal to differentiation of potential. Normally we will say E equal to minus dV by dr. dV by E is equal to, generally we'll write minus dV by dr, like this we'll write. In vector format, dV by dx into I minus dV by dy into j minus dV by dz into k we'll write. That's it. We are differentiating this one. So let's go to the solution simply. Potential equal to minus x square y plus 4z given in the question. We have our beautiful formula also available here. We'll substitute the value. Very important, I have to say, this is a very simple question, but at the same time lot of students make the mistakes in the calculation, especially the sign conventions. Why? Because here everywhere one minus signs will be here in the formula. Minus here, minus here, minus here. Because of the hurry, we have to solve in 3 hours. We have to do a lot of questions. So because of the hurry, because of the tension, or because of the nervousness in the moment, we'll make certain questions to be carelessness. It's not lack of knowledge, but please take care such things. So to not end up to that particular situation, sir, I will give you a hint. Just take a minus here, then always immediately open a bracket. Then you will never miss out. dV by dx, the differentiation of potential for x in the differentiation with respect to x. So x in the component only you differentiate. Minus x square differentiation minus 2x, y is constant, so into y. Here there is no x component, so differentiation equal to 0. So that is over. Next this minus, so this minus will be here. Open a bracket open. dV by dy, so y in the differentiations, y when a term first term on, so minus x square is a constant into differentiation of y is 1, so only minus x square into j cap minus, immediately open a bracket, dV by dz, first term is z illa, so it is 0, dV by dz, z in the differentiation 1 on ivide, so it is 4 into 1 equal to 4 is written here. Now it's simple. This minus into this minus become plus 2xyi. This minus into this minus become plus x square j, and this minus 4k. Remember this option, we have plus and minus this the option. 2xyi x square j minus 4k. Option number 3 is the correct answer. See option number 3. So see, to confuse you or to make you trouble, you see these two options, they are given exactly equal, only the difference is they're changing the sign. Second option and third option, only difference is changing the signs. But what is the correct answer? For us, it is 3. I into 2xy plus jx square minus 4k. So be very careful about the sign of this particular formula. Let's move to question number 27. Okay, 4 electrical charges plus q minus q plus q minus q are placed at the corners of a square-sided 2L as shown in the figure. Electrical potential at the point A midway between the two charges plus q and minus q will be. Question asking AR, what is the potential here? I have given you 4 charges plus q minus q plus q minus q. You tell me what is the potential here. Simple question. Question is asking potential due to a point charges. Potential due to point charges, potential due to multiple charges. These two are the two part of NCERT sections. Potential due to point charges means you have learned potential formula for one charge. And if you have 10 charges, you will repeat the same thing for 10 charges. The key interesting P point is that electrical potential is a scalar quantity. So we have previously solved the problem for electric field intensity where we have taken like E cos 45, E sin 45. We are splitting the vector electric field, we split it to cos and sin. This is always a headache for students. But potential is a very friendly guy for students because it is a scalar quantity. There is no cos, there is no sin. So electric scalar potential is a scalar quantity, but electric field is a vector quantity. We always write V like this. We always write electric field like this because of the vector. And the formula for potential is KQ divided by R. That is in a magnitude formula. We will analyze this one. Now we have the formula. We know it's a scalar quantity. We'll take it this one. We have 4 charges plus Q minus Q plus Q minus Q. We have given the numbers as 1 and 2 and 3 and 4. So I need to get the formula KQ by R. For this, R is the distance from charge to that point. For this charge, the distance to here is L, half the distance. For this charge, the distance is L. For this charge, I need this distance, shortest distance, which means displacement I need. So this is actually the displacement I need. So how to get the displacement? See, R1. So this is actually a kind of a right angle triangle with base length 2L and height equal to L. So Pythagoras theorem, R1 equal to root of 2L square. I have written 2L square plus L square. The 2L square plus E half of the L. The total length 2L, so half length L. So 2L square plus L square, 5L square there upper root to 5L R1 in the value. Now we'll calculate V1. What is V1? KQ by in the distance. How much R? R means L. So KQ by L over. V2. V2 means E part 2. 2 means K into the value minus Q, charge in the value. Formula is KQ by R. QQ in the value minus Q into R1. So I written as R1. What is R1? Root to 5L. So V2 is written. Next one V3. V3 is what will come? KQ divided by the distance root 5L. So it is root 5L V3. R2 nana distance for R2. Next we are another Q4. Q4 distance to this point is how much? L. So Q4 is K into minus Q by L. So how to find out the potential due to 4 charges? It's a scalar quantity. So you have to just add it up. V net equal to V1 plus V2 plus V3 plus V4. KQ by L minus KQ by root 5L. KQ by root 5L minus KQ by L. If you add everything, answer is equal to 0. Option number 4 is the correct answer. So let's go here and see option number 4 is the correct answer for this particular problem. So electrical potential is a scalar quantity. You have no headache like cos 45, sin 45, cos theta, sin theta, no trigonometry at all. You just find potential, you add it up. That's it. Let's move to the next problem, which means question number 28. Electrical potential at a point xyz all in meters spaced is given by 8x square plus 5. Electrical field at the point 102 in volt per meter is. This question is again taken from relation between electrical field and potential with a slight variation. Same formula, E is equal to minus dV by dx into I minus dV by dy into j minus dV by dz into k. So potential formula is given 8x square plus 5. Electric field at 102 we have to calculate. Previously, in the previous problem, they asked us to calculate only electric field. But here they are given 1 point also additionally. That's the only difference. So we'll substitute dV by dx as I told. Take the minus first. Open the bracket. dV by dx is in the x in the differentiation. 16. X in the x square differentiation 2x. So 2 into 8. 16x will come. 5 is a constant 0. So answer is 16x. With respect to y, there is no y term, so completely 0. With respect to z, there is no z term, completely 0. So minus 16i. So here I can say minus 16 into 1 into I, which means minus 16 plus I means positive along the positive x direction. Okay, why I have given here 1? Because they have given the point like 102. You please substitute x equal to 1, y is equal to 0, z is equal to 2. They are given this point. What is electric field at this coordinates? So that's what we are substituted x in 1 into I. So we'll get minus 16 along the I means positive I and positive x direction. Or I can write 16 into 1 into minus I can write. Effectively it is minus 16 I only. Okay, so their way I can say it is 16 along minus x direction. 16 along minus x direction. So that is matches with option number 3. So 16 along negative x direction. Or you can say minus 16 along plus I direction positive x or plus 16 along minus I direction. Both are actually the correct explanations. Okay, both are actually the correct. That's it. So question number 28 over, answer number 3, 16 along negative x. Let's move to question number 29. Okay. 4-point charges minus capital Q minus small q, 2 small q, 2q are placed at different corners of a square. The relation between capital Q and small q for which potential at the center of the square is 0. Potential at the center. Again, this is a potential due to point charges or potential due to multiple charges. Two sections actually is combined. Okay, so 4 charges are placed at the corners of a square. They are giving potential at the center equal to 0. So what we'll do? We only want to know the potential formula kq by r. Scalar quantity and no vector. So we have 4-point charges will be here. I have given us charge number 1. I have given us charge number 2, 2q, charge number 3, 2q, and charge number 4 minus q. So you remember these two are capital. It's given in the question. Let's take the side length as A. So we need to calculate the potential at the center. Potential at the center means we need to know, we know the potential formula is kq by r. R is the distance from the charge to that particular point. What is the point here? Center. So this distance, this distance, this distance, this distance. So we want to know all these distances to the center. For that, I have taken this right angle triangle to apply Pythagoras theorem. Here A, here A. So Z is the hypotenuse. Hypotenuse is equal to base square plus height in the square, A square. So 2A square root 2A. Appa root 2A is a complete Z length. Appa half the length means Z by 2. Z by 2 means root 2A by 2. What is 2 in the denominator? 2 can be written as root 2 into root 2. We can also written it like this one, right? Yes. So now we need to calculate the potential. That's it. So we have potential due to 1, potential due to 2, potential due to 3, potential due to 4. So we say potential equal to all potentials we are adding. V1, V2, V3, V4. What is V1? K into its charge. to the center, k into minus q by distance is how much? Z by 2. Idum Z ആണ്, full distance ആണ്. അപ്പോൾ ഇതിൻ്റെ half ആണ് we need only this distance, this highlighted distance, that is nothing but Z by 2. Z by 2 means root 2a by 2. ഇനി v2 second potential, ഈ potential ഈ distance 2q divided by root 2a by 2. So root 2a by 2. V3 third potential. Third is 2 small q on distance. So k into 2 small q divided by root 2a by 2. Third one V4 on. V4 means minus small q on. This distance, it's root 2a by 2. K into minus q root 2a divided by 2 equal to 0. So potential equal to 0. How potential equal to 0? Because question is already told potential equal to 0 at the center. Right? Potential equal to center is given. A potential at the center of the square is 0. Question is already given. So let's go here. Potential equal to 0. So here k root 2k everywhere it is cancelled, going to 0. Here minus q 2q plus 2q minus q, minus q 2q 2q minus q. So to this 2q minus q is become q. 2q minus q is plus q. So capital Q equal to minus small q, which is matching with option number 3. Capital Q equal to small minus q, option number 3. That is potential beauty in comparable to electric field. Here it has a high beautiness in terms of it's a scalar quantity. It's not a vector quantity. Vectors are both, we have to do this what can say we have to say like e cos theta, e sin theta things. Nothing will be here. It's very simple. You just find it out and you just blindly add it up. So let's move to the last question in this third part of the video, and that is here. Two metallic spheres of radius 2 cm and 3 cm are separately at large distances are given a charges of രണ്ട് sphere ഉണ്ട്. So we have a two charges, 2 cm and 3 cm, and the charges minus 1 into 10 raised to minus 2, 6 into 10 power minus 2, that they are connected by a conducting wire. Final charge on the bigger sphere is. Normally we have learned, if you have a two spheres like this, provided they have same size, charge 4 coulomb 6 coulomb, they are connected using a wire, then their wire cut and they're separated, they have charges of 6 plus 4. If you have a two charges, say for example if two bodies 4 coulomb and 6 coulomb, they are connected each other and they're separated each other like this. Now what's the charge? 4 plus 6 by 2, 5 coulomb. 4 plus 6 by 2, 5 coulomb. Provided they have the same size, but here size is not same, 2 and 3 centimeters. Separated by large distance, connected using a wire. Charges is value is different. Question is asking final charge of the bigger sphere. Bigger sphere means 3 cm radius less sphere. This question is came from the section 211 capacitors and capacitance. If you read this question, nowhere specified about capacitance, then we have a doubt how this question is come from capacitance. That is a beauty here. That is the beauty of this question. Let's learn some theory. When two spheres are connected together, then the potential is same, voltage will be same when they're connecting. Capacitance is parallel. How it is capacitance parallel? Say we have a small spheres will be here, 2 cm sphere and 3 cm sphere. Okay, let's mark here. This will have a radius of 2, this will have a radius of 3. So what happened when they're connected together? These will have a common center, common connection point, and here also it's common connection point, ground. How will say two capacitance are parallel like this connection, like this connection. So here they have one common point, here also they have one common point. So two plate, രണ്ട് side they have common point. So plate number 1 2, plate number 1 2, 1 connected, 2 connected. Here also this side connected to this side, so both are common side, and other side is also connected to ground. This also ground, this also ground. Ground means zero voltage. That's what it is, parallel connection. If the capacitance is C1, capacitance is C2, then I can say C1 plus C2 is the net capacitance. What is the voltage? Voltage will be the same. V1, V2 equal to V because they are connected. Capacitance is parallel, not series. What is the series capacitance formula? You know, C1, C2 divided by C1 plus C2. But that is not required here because here it is a parallel connection. Reason is here. Okay, now I want to find out something called common potential. So this VC is called the common potential. What is common potential? Common potential is total charge by total capacitance. Total capacitance means series or parallel, but here it is parallel. So total charge Q1 plus Q2, total capacitance C1 plus C2. What is C1? For a sphere, spherical capacitance in the formula is this one. For a sphere, capacitance is 4 pi epsilon 0 R. But C1 number 4 pi epsilon 0 R1. C2 number 4 pi epsilon 0 R2. We'll find the common capacitance. Charge like Q1 plus Q2, C1 plus C2. So what is Q1? Minus 1 into 10 power minus 2. 6 into 10 power minus 2 divided by 4 pi epsilon 0 into R1 plus R2. R1 plus R2. 4 pi epsilon 0 R1, 4 pi epsilon 0 R2. So 4 pi epsilon 0 common on. So R1 plus R2. This formula C1. Same formula is used here. The same formula is used here. Okay, the same case here. Okay, so minus 1 and 5. 5 into 10 power minus 2. 4 pi epsilon 0. Radius 2. 3 into 10 power minus 2. Centimeter and meter load converted. This 2 and 3 would add 5. This 5 and 5 cancel. If it 10 power minus 2 common, we can take it out of the bracket. At 10 power minus 2, this 10 power minus 2 cancel. Balance another how much? 1 divided by 4 pi epsilon 0. That is nothing but K. Let's keep it there. Now I have to find out the charge on the bigger sphere. Bigger sphere means the 3 centimeter or another. But I will first find the charge of the smaller sphere just for your understandability. In examination, you can directly find Q2. Here I am additionally finding Q1 also. What is Q2? C1 into V1. What is V1? Yes, now it is called VC, common potential. That's what we are find this common potential here, and we are find common potential here, and we use it here. VC. So C1 is 4 pi epsilon 0 R1. VC common potential is 1 by 4 pi epsilon 0. This will cancel. So Q1 is nothing but equal to R1, 2 into 10 power minus 2. What is Q2? Q2 is C2 into V2. What is V2? VC. Common potential, same voltage. Connected means common potential. So the aim is to first find out the common potential. Once you find common potential, Q1 equal to C1 V1, Q2 equal to C2 V2. So you have C2 4 pi epsilon 0 R2 divided by VC. VC is 1 by 4 pi epsilon 0. We calculated the common potential here, right? It's a common potential. This is a common potential. So we calculated. So 1 by 4 pi epsilon 0 got cancelled. So Q2 is nothing but equal to R2. R2 means radius, which means 3 into 10 power minus 2 coulomb. You may think like, sir, why we are doing all these things, sir? Charge is directly proportional to radius. You can say like that also. You can say like that also. If you see here, Q1 equal to R1, Q2 equal to R2. You may ask, sir, why you are doing all these things? You can directly write Q1 equal to R1, Q2 equal to... Yes, you can do like that. But you should understand when two spheres are connected together, they will have a common potential. The correct method of solving the problem means you have to find the common potential. Then you have to find Q1 equal to C1 common potential. Q2 equal to C2 common potential. You have to follow this method. Because I should insist you or I should give you a major point saying like that when two spheres are connected, both will have common potential. I will give you simple examples. Suppose we have a 240 line, electric field lines are going well. Well, once we touch there and if our ground is touched on the ground, once we touch on the line, leg is touched on the ground, you will get shock. Why? What happened? The lines will have an electric field of 240 volt and you will have an electric field of 0 volt. So this 240 volt will flow through your body and your body and the line both are making 240 volt. Potential same, you get shocked. So most of the cases we will say, but at the same time in another say. and electric field lines are going on, you are hanging on electric field lines, and you are not making a potential, your leg is not touching on the ground, and you are not creating a potential differences of 240 volt. You have scenes like the birds are sitting on an electrical lines, but they're not getting shocked. Why? When a crow is sitting on a electric field line, both the leg will have same potential, 240 volt, 240 volt. So what is the voltage difference? 240 minus 240 is 0. It never gets shocked. But when a crow is sitting one leg in one string of copper wire in an electrical line, 240 volt high current, other line touches on other line, if it has 0 voltage, then a high current will flow through the body of the crow, because the electrical wire have 240 and the body of the crow when touches on the other line will have 0 voltage. 0 voltage means one leg 240 volt varum, oru bird inde one leg 240 volt varum, ee vera leg vera oru another electrical line touch cheyidina, if their voltage is equal to 0 means 240 minus 0, 240 volt current will pass through the body, blood will clot passed away. At the same time, if the two leg of the bird placed on the same electrical line, then both are 240 volt, no current will flow, no potential difference. So potential difference is equal to 0 when you are connecting using two body having a different potential or different charges. If you have different charges or different potential, when you connected using a copper wire, a conducting wire, both will acquire a common potential. It's very important to learn this one. I hope you understood. If you have any doubt, please put it in the comment sections. I will answer to your doubts on this one. I hope you are get benefited from this video, and we will see in the part 4 video. Okay, so all the best, and I wish you a happy learning and happy preparation time.